Geomagic Control is a versatile, highly customizable software solution for automating inspection processes using data from portable metrology devices. In this video, you'll see how you can set up an inspection process on a reference file, then use the scripting tools within Control to run a completely automated inspection process using a 3D scanner. Once a script is created, Geomagic Control will run completely independently, so you can inspect hundreds or thousands of parts quickly and accurately. The first step in setting up our automated inspection is opening a reference file. This can be a 3D scan of an accepted part in an STL, OBJ, or many other point cloud and mesh formats, or a body created in a program like SOLIDWORKS, CATIA, Creo, ProE, or Inventor. Control will open up files from those programs natively, or generic CAD formats like IGES and STEP, as is the case with the reference file here. Because this is a CAD body, Control assumes it's the reference object all scans will be compared to. We'll need a test object to continue, so if we had a scan of our part, we could import it now. But I haven't scanned anything yet, so I'll just copy my CAD body and set it to be the scan's stand-in. While the copy body lies perfectly on top of the reference object it was created from, it's unlikely that subsequent scans will. Aligning them will set relations between the features on the reference object and the incoming scans, which is useful for most inspection processes. If any GD&T callouts reference specific datums, though, Control will align to those datums in the background when analyzing that GD&T callout. Once I hit apply, I can check that Control is saving my steps for future iterations of this inspection, so this process only needs to be set up once. I'd like to see how the overall shape of my test object matches that of the reference, so I'll start inspecting my part with the 3D Compare. This tool gives me a color map of the gap distance between the reference and test objects. I can set my tolerance boundaries and click Apply. Control will then create a result object in the Model Manager, which isn't useful right now as the reference and test objects are exact copies. We'll set that aside and revisit it when it's more meaningful. If we're interested in the deviation at specific locations, adding annotations is as simple as clicking on the model to create a tag. More information about the point selected can be found in the annotation view box below. I can take slices through the result object to see how my deviation looks in 2 dimensions, but first I need to create a feature from this planar face. Then I can use the 2D Compare tool to create a whisker plot of the deviation on that slice. Again, since there's no deviation between the test and reference objects, this will be more useful later. Adding GD&T is as simple as selecting the callout you need from the list, clicking on the face to apply it to, and setting the tolerance. No inspection would be complete without taking some dimensional measurements, which I can do in section mode. I can use a best fit to the cone section for the angle, and virtual calipers to get the maximum dimension on these drafted faces. The options menu lets me customize how this dimension is displayed and the tolerance associated with it. Once we have everything we need, we'll generate a report and save it to a specified folder. The report can be reviewed in a PDF reader, and now it's time to put this inspection to the test. Here's the final process Control will use to inspect our scans from start to finish. From here, we could manually scan items, import them into Control, and run the inspection process on them. But the real power of Control lies in its automation and scripting options. I wrote a Python script controlling a 3D scanner to save scans to a specified directory. Now I can open GeoAutomate and set it to watch the folder scans are being saved to, and tell it where the inspection file to run is. When GeoAutomate is initiated, an instance of Control is opened in the background that waits until new scans are loaded. When they are, Control imports them, loads the inspection file, runs the inspection process, and saves a report. It then goes back to watching the folder and repeats this process until the user stops it. Not only is this process fast, it's flexible, easily changed when needed, and runs completely independently of an operator. Here's the view of my report once I've ran the automation on some scan data. This is just one simple example of the automation that Geomagic Control offers. Companies around the world use Control every day to inspect their parts.